So I want to talk about building React applications with security in mind to stop a couple main risks when you're building client-side or even server-side React. But I've kind of changed the talk a bit because we're moving into the era of AI code creation, and I wanted to take all of this research and theoretical ideas and put it into practice with prompt engineering so you can recycle these techniques over and over again throughout your team when you're using AI to generate code. Who here believes in AI as a good tool for software engineering? Who is a doubter and thinks AI is not a good idea for software engineering? Anybody? Okay, those of you who are not believers, I'm going to change your mind because a lot of us today, a lot of the research about how bad AI is at writing code is raw prompts, is opening up a tool, doing no training in that tool, and then just asking it to write code. And if that's your life cycle, then AI is actually a very bad coder. But if you bring in a junior coder into your team, what do? You train them in what your styles, security, your guidelines are so they can be more effective in your team. And if you do the same thing with AI, it goes from being a bad tool to a tool that will change how you write software. And just to prove these points with a few of my team members, a few of us bid on a project recently that honestly would have taken us a year to finish. We're all experts in using AI to generate code, and we finished the project in a week and made some decent money doing it because 3 of us were architect-level developers leveraging 4 different AI engines to write the code for us, to write the unit tests for us, and similar, and we got project completion stamped by the company in 8 days and got paid out for a year's worth of work. So this, and I'm not saying that to brag or to be a capitalist. Yes, I'm American. I'm saying this because this is a sign that times are changing. I can do it, and so can many other developers around the world, finish large projects quickly, but you need to know how to use AI correctly. And by the way, we're going to look at React. We're going to look at how to build secure AI React, so AI goes from garbage to something extremely powerful. We'll look at key concepts, challenges, best protection strategies, and how to reuse this information over and over again by using secure prompts that will work on any of the main AI engines today. My name is Jim Manico, by the way. I've been a software engineer for 27 years professionally. I've been writing code for about 41 years now. I'm a former board member of the OWASP Foundation, a security foundation. I wrote a book on secure development, and I work on several projects to take my knowledge of security engineering to push it out to the open source world through documentation. So the life cycle of building secure code with AI, number one, you need expertise. You can't depend on AI to do that for you. If you work in a team of many developers, what percentage of your developers do you think understand security engineering well? In my experience, that's about 5%, maybe 10%, and maybe higher for certain specialized teams. But what happens to those specialized team members who really understand security engineering? They typically don't stay. They leave and go find other jobs, and then you lose that knowledge. So number one, you want to create clear security rules that are very, very specific. And I'm going to show you many examples today. Very specific. So you're capturing the knowledge of your security architects that you can use forever in future development. And then you create specific AI prompts from those rules, and then you generate code based on those rules. Just dump those rules into AI before and after you generate that code to apply these security rules. And then you look at what was done right and wrong. And if there was a mistake made by AI, then you go back to your prompts and change them so they're more effective. Because in the very near future, if not today, the rules that you tell AI to generate secure code is going to be more valuable than the code you write itself. So all of you, especially if you're in a big team, start capturing the rules, converting them into AI rules, and use them. So number one, we have to identify security requirements. This is like the core security principles of input validation, authentication, cryptography, but very specific, as if you were teaching a developer how to get this right. Then we want to translate those into a prompt structure that AI can understand, and AI will help you do this. Then we want to actually generate the code with AI and reapply those rules, and then go back and iterate and refine your prompts over time until they hit a point where they're actually doing their job correctly. The other thing I do with AI is I use a bunch of quality metrics to encourage React apps to be built with good design. The three main things I look at are cyclomatic complexity, cognitive complexity, and high cohesion. Cyclomatic complexity means there's a low number of possible paths through that code. It makes it infinitely more readable by a human and more maintainable. Number two, cognitive complexity. Advanced developers who are doing clever things are dangerous to your team. The real senior developer develops code with a low cognitive complexity, so it's maintained over time, period. Clever coders and teams are destructive to the future of your software. And I went through that arc myself. I started learning advanced object-oriented design patterns. I started using them for fun, doing really clever, like one line, doing multiple conditions. This is destructive to maintaining software. And if you're a clever coder, stop it. Start writing low cognitive complexity code for the sake of maintenance. That's what a real professional coder does. High cohesion is about how well related the responsibilities of a module or class over. What this high cohesion means, your module is easier to maintain and less error prone and a lot more reliable. So the first three prompts I built for AI is maintain low cyclomatic complexity, minimize cognitive complexity, and apply high cohesion in how AI will write software. Now that's a start. Let's go to React. React is the main UI framework of the day. It's the most popular JavaScript framework, primarily used client-side. And the two big risks are view source, and I can see all the work you're doing, like hard-coded secrets and access control. Hey, by the way, how much access control should be in client-side React, developers? 0! If you said 0 right away, raise your right hand real quick and take your left shoulder forward and pat yourself on the back. A lot of people get this wrong, and you get it. I applaud you. Next, it's content injection, otherwise known by the misname of cross-site scripting. So first of all, when I view source, here's two problems. A hard-coded secret, I got your secret. And if user role is admin, show this code. This is not how you write client-side React. This is an example of problems in security that we see within source every single day during security reviews. Other things we shouldn't do in React are things like excessive permissions, unsafe lifecycle methods, direct DOM manipulation, inline scripting, props or types without sanitization or validation, storing sensitive data in something like local storage, using deprecated or vulnerable packages, misusing third-party libraries, or not validating a user-driven URL. But let's take these ideas and codify them. So number one, we have cross-site scripting. And there's a lot of examples of real-world cross-site scripting that's done destruction in the world. So this is a risk we do have to deal with if we care about web security. And one example of this is I may have a parameter in a URL that's directly added to a user interface. I modify that parameter, add some JavaScript, send that to another user. They click on it. That JavaScript payload is added to the page. And now as an attacker, I can execute untrusted JavaScript that I authored on someone else's web page. The more common vector is stored cross-site scripting, where I'm implanting the attack in your database. I got a bug bounty in a social media site. I put JavaScript in my user profile, so when somebody else looked at my user profile, the JavaScript that I authored, not the developer that I authored, would land in my profile page, and I could do all kinds of nasty stuff like this. Some of the things I can do is I can use evil JavaScript to steal a cookie if it's not flagged HTTP only. This is one of the original attacks we saw at Microsoft Research back in the late 90s, like around 98, 99. What else can we do? We can steal any data off the page. Here's a script with the URL. I'm using JavaScript to grab that value and using an image, which has no domain policy by default, to ship that data to my evil collection site. I can steal any data with malicious JavaScript. A lot of developers put session tokens and sensitive data in local or session storage. This is a bad idea. You do not want to. Where's a good place in the browser to store data long-term securely that's sensitive? That would be nowhere. You want to use cache removal and store nothing you care about long-term. And if you put it in local or session storage, here's an attack that grabs session storage and local storage, stringifies it, and ships it off to my attack server. A very common attack when stealing data with cross-site scripting. Or I can force your browser to make any request. It's called same-site request forgery. Here's JavaScript, uses an image tag to make a request back to the same domain, includes a cookie automatically, and triggers a website to do any action as the attacker I want you to do through your browser. I can set up a keystroke logger in JavaScript. I can deface the whole page any way I want with document body inner HTML, right? I can also obfuscate my attacks so the attack has no letters or no numbers, and worse, making it easy for me to bypass firewalls and validation layers. And I can also do things like build a polyglot. There's a URL that's a JavaScript URL. It's a legal URL. It bypasses web firewalls and lets me execute JavaScript on your page maliciously. Here I am fetching a login page and altering the action to be a malicious login page so I can collect your credentials. Cross-site scripting is real. Now let's talk about React defense. I want to make sure I hit these main 10 defensive categories, and we're going to codify these rules in AI prompts. So number one, cross-site scripting. Now React uses JSX, and so does Svelte. I believe Vue does as well. A lot of different engines use JSX. React depends on JSX to auto-escape for you. Do you think I can attack a variable that goes through your mustaches in React? Can I get cross-site scripting through React's escaping mechanism? What do you think? Anybody think this is possible? How? Okay, what's that? You got it. That's what I'm here for. So here's the raw data, and there's data at the bottom going through our mustaches, right? The characters are escaped. The code will be displayed on the page when you go through JSX, but it will not execute. That provides the security. Now, there's ways to bypass this. So number one, when you're doing create element, there's three major parameters, right? You got your types, you got your props, and you got your children. The children are auto-escaped, but the types and props are not. And so this is a pretty big problem. So number one, let's take a step back. The first rule I tell React is encode user inputs. This is an actual AI prompt I use in my work. Generate React code that displays user input securely. Ensure the user input is placed inside JSX using curly braces so React automatically escapes the content to stop XSS. Avoid using any other method that bypasses React's escaping mechanism. The goal is to show exactly what the user typed without allowing any injected scripts or HTML. Now look at the detail of this. I'm not messing around. I'm doing it with extreme detail so AI has no question about what its job is and why I'm doing it. It's the rule and an explanation of why. And this is worth its weight in gold when you begin to collect these rules and apply them to AI code creation. Now, the problem with props is props are sometimes used in a dangerous attribute in HTML. What's the example? Are we taking pictures? Let me look smart. Go ahead. Hit me up. What's the danger of an unvalidated prop going into an attribute, right? Like on click, on blur, all the event handlers are dangerous. Or how about all the URL mechanisms like href, source, action, form action? I can put a JavaScript URL and execute script through many of the URL handlers within an attribute in markup. So, what do we tell our AI for React? Enforce safe usage of create element types. Validate the type argument of React Create element to ensure only safe, expected HTML tags or trusted React components are used. The type should not be dynamically generated or constructed in a way that introduces security risk, like an injection attack. If custom components or dynamic tag names are necessary, ensure they're strictly validated to prevent unsafe execution of code. Avoid passing untrusted or user-generated input as the type argument. This can lead to security vulnerabilities like rendering arbitrary elements or executing unwanted behaviors. Clear, explicit instructions. It takes AI from being a junk coder to an expert security coder. And the thing is, it's not about me telling you how to do this. You're already on a smart team. You already have experts around you that come and go. They may be consultants. Anytime a security development expert comes to your company, you convert their knowledge into this level of detail and put it under source control and save it forever. And you can use this to review and create secure React code. It is mind-boggling how well this works when you capture the knowledge at this level of detail. What about a prop? Validate all props using prop types or similar to ensure that only safe, expected data is passed into a component. Props should only be used in attributes that do not execute code, like onClick and onload, or handle URLs, href source and action. If a prop needs to be used in a URL or executable attribute, it's got to be strictly validated or sanitized using a library like DOM Purify, and escape to prevent injection attacks or unintended execution. Avoid passing props directly into attributes capable of triggering JavaScript execution. Clear, specific rules. It changes the game. Now let's look at a few more things. Other things I can get wrong are things like dangerously set inner HTML, that's living dangerously, JavaScript URLs, styled components in React, embedding JSON into a React page, or building React templates server side. Let's go through all of this. Let's start with dangerous URLs. This is the main way I bypass React's escaping mechanism. Google research tells me that 1/3 of all successful attacks against their properties are with an untrusted URL rendered in an anchor tag or similar. Let's take a look at this. This is my main bypass against React. I look for href equals open mustache, and I search GitHub, and I find thousands of vulnerable React apps, because you should not put a user-driven URL directly into an anchor tag. Even if you validate on the server, you still have insecure React code. My bypass is something like this. A JavaScript URL and an anchor tag should no longer be supported. That will deface the whole page or any other attack I just showed you. This is how I bypass JSX, the number one way. It's, again, about 1/3 of all successful attacks against top-tier companies' web properties. This makes sense, everyone? See how simple this attack is? Now, where's an untrusted URL show up? In a user profile, I may have a home page that you turn into an anchor tag. It might be a URL from a redirect. I see it in a lot of different, especially social type of applications. And the problem is, even if I put it in JSX, and that form action payload does get escaped, but an escaped URL and an attribute still fires. So the escaping doesn't protect that attribute from executing a JavaScript URL. What I need to do is validate the URL, not at the API. Hey, React developers, how much should you trust API developers in terms of giving you safe data? I need your answer, sir. Same answer as before. How much should you trust an API developer giving your beautiful, gorgeous React application, JSON? How much should you trust that that data is secure? Say it! Say it! None at all. Thank you. None at all. So why would you put a user-driven URL in an anchor tag raw? You're asking for trouble. Instead, validate, just like Angular does. It does this automatically. React does not. And so I have that. This is the problem. And even your linters will say, that's an eval. That's code execution. Don't do it. You'll get console warnings since React 16. And React 18 does not block this well yet at all. Here's the code that we can't see. It's a giant regular expression on line 22, the worst way to address this problem. React's got a ways to go before this is fixed. So there's the problem. And the way to fix it, is you actually do URL validation in React. I'm checking if the protocol is HTTPS and a legal URL in this example, and that's the bare minimum we can do. I can also limit what domains and similar that URL is allowed. But this solves the problem right there. This should be built into React, but it's not. It is in Angular. Also, if I'm going to put untrusted data in an anchor tag, I recommend you do target as blank and have no opener and no referrer built in as well. So let's codify this so we can get AI, even if we're just using it to review, we can codify this knowledge. Validate and sanitize URLs. Ensure that user-provided URLs are strictly validated for correct syntax and allowed only if they use secure protocols like HTTPS. If the URL is not valid or does not use a secure protocol, reject it or replace it with the safe default value. Additionally, sanitize URLs to prevent injection tags or unsafe characters, especially in attributes like href, source, action, or any other URL-related field. Always escape URLs to prevent potential injection vulnerabilities and avoid dynamically generating URLs without proper validation. If URLs are executable, ensure strict validation, blah. That's the level of detail you need for your prompt, and the difference is night and day. Next, rendering HTML. So in this case, I'm using a WYSIWYG editor like TinyMCE. I'm old school. I like Spock's TinyMCE. He's the name of the author of this. If you're one of the new cool kids, you're using Fraola or one of the others, but they're all the same nonsense. They let a user submit HTML to your server. How do you make sure that a WYSIWYG editor submitting untrusted HTML to your server is safe to render? How do you handle this problem, developers? What's that? You're going to write your own HTML sanitizer from scratch? I hope not, right? But what do you have to do in React to get user HTML to render? If I put it in a mustache, what are you going to see? You'll see the HTML on screen. So what do you have to do to make sure user-driven HTML renders? It's the first answer on Slashdot. You got to use dangerously set inner HTML. If you're using this function on raw user data, then what kind of life are you living? You're living dangerously. Thank you. Thank you so much. So what do you have to do? Got to use DOM Purify or a similar HTML sanitizer, not on the freaking server. Do we trust API developers? NITOC. No, thank you. No. What do? We sanitize in React itself by using DOM Purify. So anytime I use dangerously set inner HTML, I use DOM Purify sanitize. I may even beef up the library to limit what domains images can pop from. I can even configure the URLs to be limited by certain domains. So bad is raw DOM Purify. Good is when I'm using, bad is dangerously set inner HTML raw. Good is when I'm using DOM Purify before I put any data into dangerously set inner HTML. So I got a rule for that, like everything else I do, right? Avoid using dangerously set inner HTML whenever possible, as it introduces significant security risk, including cross-site scripting. Now, if its use is absolutely necessary, like when you're rendering untrusted or dynamic HTML, make sure the content is sanitized using a trusted library like DOM Purify to remove any potential harmful scripts, unsafe elements, or malicious attributes, and always make sure that only sanitized safe content is rendered, and consider safer alternatives when possible, like doing markup rendering, a little bit safer. We're building rules. Again, your security architect shows up. He's got these rules. He helps you do some code review and leaves, and you lose that knowledge. So you bring in a security architect, get them to codify these rules, and that knowledge is preserved in your team forever. Or just steal my slides. Okay, securing JSON. If you look at the original Redux documentation, they would recommend you you embed the initial JSON in window init state or window preloaded state. Why? It saves a round trip to the server. Normally, I make a request, get my HTML, make an XHR hit, and I get back JSON and render. That's 2 hits. I can make things faster, especially on a mobile network, and just embed the initial JSON in something like initial state. This was recommended for some of the state management tools like Redux, and they said to stringify the JSON. This is a security bug. You don't want to ever stringify data on a web page for the most part, especially JSON. And so the attack was this. I have JSON where my address is end script, start script, alert with a couple special characters to end the JSON early, and I have an address that, as long as it takes a couple of these characters, will let me bypass stringify. So the way to do this is if you're doing Node and on purpose doing JavaScript on the server, it still hurts me to say that. I'm sorry. You can serialize JSON, which is basically encoding using JavaScript hex notation. So you can serialize the JSON. You can encode the JSON with JavaScript encoding. You can use a JavaScript escaper. That will work as well. And make sure that JSON is in quotes in your markup, and the problem goes away. So when embedding preloaded JSON into the DOM with the window init state or similar, to save a round trip, do not use JSON stringify. Instead, ensure JSON is safely encoded or serialized before embedding it, plus some extra detail here. Codifying the rules so we can reuse them over and over. Dangerous styles. So when you're using a styled component, a lot of developers will drop user-driven data into a styled component to let the user drive a window size, to let the user drive a font, to let the user drive a color. And a lot of React developers won't escape it because the escaping function I'm going to recommend doesn't work in IE 11. Yeah, IE 11. That thing's dead years ago, right? But untrusted CSS. This is called cascading style sheet injection, a form of cross-site scripting, basically. I can do stuff like steal passwords with CSS. I can steal data with CSS, like your cookie or any other data on the page. And so you want to use CSS escape in your styled component wrapped around any user-driven variable, and this problem largely goes away. There are some you have to really figure out how to use CSS escape properly. It's not on a big block of CSS, just on a variable that's driven by a user. If you have a user authoring a big chunk of CSS, you need a CSS sanitizer. That's a different problem. I don't even recommend you let users author CSS. That's too big of a problem in general, right? So here's CSS escape in action. Look at the fifth line of code from the bottom up. Element style set property, my variable. CSS escape, a native JavaScript function in every major browser, solves the problem. When using, here's the AI rule. When using dynamic values in React styled components, ensure that any user-generated or untrusted input with CSS is properly escaped using CSS escape, plus a bunch more details explain the context. Should you modify the DOM with the ref in React? Come on, I'm going to give you a chance to confess. Who loves to use refs in React to modify the DOM directly? Confess your sins now. You do? You edit the DOM directly with the ref in React? You are a React sinner, my sir. You are in a state of React sin. Please don't manipulate the freaking DOM with the ref, like create ref. This is bad. You're circumventing all of React security. What's wrong with you, damn it? Oh, sorry. Now, if you're doing programmatic focus, scrolling, or a click away handler, that's fine. You need refs for that. If you're using a ref to read out of the DOM, that's okay. But editing the DOM directly? You're crazy. What's wrong with you? What's your name, sir? Ziggy, I expected better from you, Ziggy. But Ziggy, if you can't stop, won't stop, let me give you some advice, because I love using refs to edit the DOM. If you really got to do it, and I can't stop you, then please use text content, insert a JSON text, a safe attribute that's not an executable or a URL handler, or form field.value, create text note, or create element. Those are all safe text-only renderers, so you can use a ref directly, even though it's a React sin of the worst order. And if you're going to do anything else and you're not sure if it's a safe sync in JavaScript, then just wrap DOM purify around the variable, and at least your sins are like a minor sin, not like a destructive sin. I love refs. Why should I do like 2 lines of code when I can do 1 ref, right? Okay, sorry. These are safe attributes for the most part. These are almost safe. They're URL loaders. That could be a problem. But let's make an AI rule. Restrict ref usage, restrict ref usage to safe operations, especially if your name is Ziggy. Avoid using refs to edit the DOM directly in React, as this bypasses the virtual DOM and can lead to security risk and performance issues. Refs should only be used to read the DOM or to handle specific use cases like programmatic focus, scrolling, or click-away handlers, etc. Now we've codified it. Next, access control and exposure failures, right? I can view source on client-side React. I can see all of your access control code, any kind of form you're hiding with style. I can view source and see all of it. I was part of an audit. I saw a cookie that said role is user. I flipped it to admin and got to all their admin forms and said critical vulnerability. Their security officer said, we disagree. People have found this before, and we don't think it's a real vulnerability. We're sick of people telling us about this. And I'm like, yeah, I'm pretty sure it's critical, and I can prove it to you. And there's a gambling company out of Europe. I'm like, you want to bet to the CISO? He's like, I want to bet. I'll bet you if I get this right and you agree it's critical, you double my salary just for this week. And if I'm wrong and you don't believe it's critical, then I'll do free work. Then my work this week is free. And he's like, I'll take your bet. I'm like, give me a contract. And he gave me like a 2-paragraph contract to this, like a week late, like a few hours later. It's on. So I'm like, okay. I get the CISO and the CEO of this gambling company out of Europe. And I'm like, I create a new user and I flip the cookie to admin, role as admin with the cookie editor built into Firefox. And I go to their, and I see all the admin functions. And one at a time, I hit every single admin function, and the server blocks it. And they're like, see, we told you. We're doing admin protection API-wise. We don't think it's critical. And I'm like, wait 1 second. So I open up a Google Doc, and I say the name of the company, enterprise customer list, and with Google Doc, I go back to the app, and I go to their edit enterprise customer page, and I try to submit it, and it blocks me, right? But what they left in the metadata of the enterprise customer field is a list in the drop-down list of every single enterprise customer they have and how much they have left in their budget for gambling. They let their staff, some of their staff gamble on like football games and similar. So I'm like, since this is not a critical vulnerability, I'm going to take your whole enterprise customer list and how much money they have left in their account to gamble with your company, and I put it in my copy buffer, Control-C, I'm copying it, and they're already getting mad at me. And I'm going to paste this into the Google Doc, and it's mine forever unless you admit this is a critical vulnerability. Control-V, I got my hand on the control. I'm going to hit V. Say it. And they're like, all right, we agree. It's critical. Yes, on film. So you don't mess with this crap. Don't mess with it. You should not do access control in React. And you got to build admin forms, right? Make it a separate app, a separate template, a separate domain for that matter. Isolate roles into different buckets. I've gotten bit doing this so many times. The principle of least privilege rules here. And so something you can do if you have tight API security is use lazy loading to dynamically load navigation, other components, server side, and only if that server side hit approves of you being an admin do you dump the admin code. That's kind of a cheat way to do it, but it works really well. Now I can mix admin and user code, depend on lazy loading and API security to save me. But overall, I really recommend administrative isolation and treat React as a thin client side. Do not rely on client-side code for access control in React as it's visible and modifiable by an end user. Client-side access control mechanisms like hiding or showing UI elements are based on user roles, can be easily bypassed using developer tools. All critical security and access decisions should be enforced server-side where permissions and roles can be validated securely. Validate permissions before returning any data or UI elements to ensure that sensitive information and actions are appropriately protected. Again, you use this when you're using AI to write or review your existing code, And I promise you, if you take my presentation, steal this video, those of you who do not believe in AI for code generation, use this research and experiment yourself, and I will change your mind in about 15 minutes. And it's just another tool. I still need software engineers in the world. Your job's not going away. But why would you not want to use a tool that increases your efficiency by 60 to like 1,000% based on your skill level? Why would you not want to finish a project in a fraction of the time using these tools to help you do it? We still need coders, but throughout history, are you writing assembly anymore in your work? We used to a couple decades ago, and we don't anymore. Guess how fast we are compared to assembly coders? We're a lot faster. And those who use AI enablement in their software engineering are going to be more efficient and more powerful than any standard developer today. And it's not just me saying this. It's already happening in the real world in a variety of different teams around the world. So don't shy away from this. Learn how to master it by using your existing expertise to codify the rules at this level of detail. How about third-party libraries? The third-party library ecosystem of React is a morass of insecure filth that no one should ever use, with the occasional diamonds. Did I get my point across clearly enough in that? Was that clear? And like, if you're a JavaScript developer and you want to build a new user interface framework from scratch, then you should be banned from software development for 3 years if you even think about doing that. Sorry. So these React components do not come with a security guarantee. Please check your dependencies using a variety of different JavaScript scanning tools. And also, before you use a third-party component, do a little due diligence. Check that code out. And these apps that have like 500 React components, stop doing that. That's nonsense. You can't guarantee security when you overuse third-party React components. Ziggy, I will miss you. Have a good day, sir. So avoid dependencies that use dangerously set inner HTML, unvalid URLs, or any of the patterns that we just talked about. Do a little review before you pick up a third-party library. There's tools like retire.js, npm audit, or ESLint help you understand if you're using an insecure library. And here's my prompt. Ensure that AI-generated React components and any dependencies are based on the latest stable version to guarantee security, performance, and compatibility. So when you're initially writing AI-generated code, it's going to make the best picks. Also, when integrating third-party libraries into React, avoid those that rely on unsafe practices like dangerously set inner HTML, unvalidated URLs, or other risky patterns that directly manipulate the DOM, and some more information that backs that up. These are my 2 third-party library rules, and it changes what AI builds for me like night and day. Coming to an end here, open redirects. We have open redirects where I have a user-driven parameter in a URL. I can modify it to be an evil domain, and I can use these kind of workflows in a login page to steal credentials, to redirect you to a fake login page on my domain where the user logs in, I collect their password, and redirect them back to your domain. This is a common attack when you have an open redirect where user variables are driving a redirect flow. So the problem is, though, validating a URL is non-trivial in my experience. So things like checking if a URL contains a domain or if a URL starts with the domain can still let me modify the URL in a variety of different ways like we see on screen. The OWASP Security Working Group says stop validating URLs, use allow lists that are very specific, where, like this, where you're saying, if the URL equals one of several URLs, then use it, otherwise reject it. So my AI rule is, when handling redirects in React, do not trust user-provided or query parameter values directly for redirect destinations. Always validate and sanitize the destination URL to ensure they point to a trusted domain within your application. I'm going to leave it at that for now. Last, server-side rendering. There's 2 problems. If you're doing SSR and you're putting a raw variable in with the render to function, you got cross-site scripting. Or if you're if you're building a template server side, that can lead to template injection. So my rules are when using server side rendering in React, ensure that all template construction is secure by strictly validating and sanitizing any data that's rendered on the server using React's typical methodology. A lot of folks who are doing like old school server side templates and want to convert those templates to React, they make this mistake where they're grabbing a user parameter and embedding it inside of a React template server side. This lets me modify the entire template, and I can bypass it with this little attack here that lets me now steal any data from the page or force the user to make any request. So avoid dynamically creating or constructing React templates with untrusted or user-provided data. This can lead to template injection vulnerabilities. All right. A few notes for React developers as we finish up is I love ESLint. I use ESLint with the security plugin and the React plugin to aid in my work. So let me show you one last thing here. So what I'm going to do is I'm going to say, build me a user profile page in React to include, see if I can pull this off quickly. Hello. So build me a user profile page in React that includes first name, last name, home page, URL as a link, a profile description that allows HTML, and a username, but use a raw prompt and drop all the rules that I have in memory. So where's the vulnerability, right? So the vulnerability is dangerously set inner HTML on the raw description and an anchor tag right here with the home page. Those are two vulnerabilities in AI-generated code when you're using a raw prompt. And I'm going to apply two of my rules here. I'm going to apply these two rules. The validate and sanitize URL rule that I used in the presentation right here, and the minimize use of dangerously set inner HTML rule. Those are the two rules that I showed you directly on the slide, and let's see what our AI engine does when it knows about those rules. Right away, it builds a URL validator that makes sure it's a legal URL and it's HTTPS. The other thing it does, it uses DOM purify sanitize on the description, so the user homepage has gone through a URL validator, and the actual description before it goes through dangerously has gone through DOM purify. Applying the right rules will fix legacy insecure code or encourage AI to build secure code for you. With 2 minutes to spare, that's my story. My name is Jim Manico. I'm an educator in the world of secure software. Please keep me in mind. You can find me at jim@manico.com. A recording of this talk and all of my slides and all of the prompts I showed you will be delivered to GOTO for your own work. Go forth and write secure code. Thank you for your time, everybody.